Hello, hello, it's Matt the Fanatic here. Today we're going to be talking about translating a function. We might as well just get started, and if there are any questions, you know where to leave them down below. So when you're shifting and reflecting and doing all of that, there are a couple of things that you want to remember. I think the most important thing that you want to think about is the fact that f of x is equal to y. You always want to keep that in mind. And if you keep that in mind, it will make doing these reflections a heck of a lot easier. Alright? And so when I say y, I mean that's my y coordinate when I put something into the function. You give it some input, output is the y. So the end result, the f of x, the f of -2, the f of 4, whatever it might be, the end result is your y coordinate or your output, right? Your element of your range. So now we're looking up here at these 4 example translations, and I'm not going to go in order. There are a couple of things I want to take a look at first. We'll look at number 2 here first. It says half of f of x. So if f of x equals y, this is essentially saying half of your y. That is half of your y coordinate. So here is a given function that is apparently represented by f of x. It's a relation connected by segments, or I guess these points that are connected by segments. And for these given points, if we just move these, since they're just segments, the segments will move with them. I'll just keep the dots connected. So if it's half of f of x, or half of my y, I go to my coordinates, and all I need to do then is take half of that y value. So for half of 4, that would be 2. My x coordinate does not change. Notice it says half of f of x, so the input did not have any shifting or reflecting, any translations of any kind going on with it, just the output. It's half of f of x. So -2 stays the same, but I take half of my y, so half of 4 would be 2. That would put me at -2, 2, so that point would be translated about right there. And then I'm at 0, 3. Same thing here, half of 3 is 1 5/10. I'm still at 0. That puts me halfway to the x-axis. That point would be there. Half of 0 is still 0, so this point actually is not going to move anywhere. And then half of -1 is 5/10, so this moves halfway to the x-axis as well. So there where the points are going to move, and I end up connecting those dots. Now you can't go wrong with orange. It's always a good color. So we'll stick with orange, and we'll connect those dots right up. And there is our translated function. It's about half the size vertically as the original function. I'm going to go ahead and erase that now. And we'll take a look at another one. So this one right here is one where I'm going to have an actual x translation first. And the shortcuts for these are given in class usually, and if you're talking about just arithmetic translations, the translations that are done on x move you left and right, and the ones that are done on y, or your f of x, they're outside the parentheses, those move you up and down, or vertically. So remembering which direction is really strange, because it's not how you would expect it. When you see minus, you think going in the negative direction, and in fact for the y's this does mean to go down 1 unit. But for the x's it's different. This one actually means go to the right one. And I always sort of imagine the minus sign as being an arrow pointing to the direction you're supposed to go, or to that number. So this is like saying x, move it to 1 to the right, because 1 is over on the right. I don't know. However you can remember it, you know. But so it's opposite for horizontal, and just how you think it would be vertically. Alright, so let's keep that in mind. But again, all we're going to do is start with the original point, and we are going to move it according to those translations. So we're always going to start within the function first. You always do the stuff outside the parentheses last. So we'll start by moving the x to the right 1 unit first, and then the y will go down 1 unit. So I start at this point, I go to the right 1, and then I go down 1, and this is where D moves. Now I go to this point, I go to the right 1, I go down 1. This is where C moves. Go to this point, I go to the right 1, down 1, There's where B moves, and then I take A to the right one, down one, and that's where that one moves. So that one is a purely a congruent transformation. The original function didn't change at all. It still looks exactly the same. The whole thing just moved to the right one and down one, but you can see that all the segments are still the same length, nothing shrunk, and nothing stretched. Alright, I should probably keep track of the ones that we're doing here. Let's see, we did this one first, and we just did number 1. Alright, and so for the other ones, when you have a negative sign on the x, what that does is it flips the function horizontally across the y-axis. So everything is going to move across the y-axis. So f of negative x, the first thing I'm going to do is I'm going to reflect, this is a reflection, across about the y-axis. I'm going to reflect every point across the y-axis. If it's on the left, I'm going to go on the right. If it's on the right, it's going to end up going to the left, and it has to be the same distance away that it was first. And then we see that we've got a number out here. It's positive. That means I'm taking my f function and I'm adding 1 to the y value. So I'm going to go ahead and do those in order. Again, you start from the inside of the parentheses and work your way out. So I'm going to take this d, and I need to reflect it across the y because that says negative x, so I reflect it across, it goes over here, and then I add 1 to the y value, so then I go up. Over here, reflecting it across just keeps it right where it is, but I still need to go up 1. And then down here, B, reflecting across moves me over here, I go up 1. And then the A, reflecting it, it's 3 units away right now, so it needs to be 3 units away over here, and then I go up 1 to there. Probably shouldn't have made that mark down there. But you get the idea, right? And then we can connect those points. So, again, no stretching or shrinking. It was a congruent transformation, just a reflection about the y-axis, and then the whole thing moved up 1. And now we can mark this one off, and so then we have one more to go. This one includes a horizontal translation because it's inside the parentheses. Can you guess which way this is going to be? It's going to be the left, yeah, I'm sure that's what you said, of course, because you're following along diligently. That's going to be the left, right? It doesn't make sense if it's inside. Positive means go to the left. And then we're going to take that y value and we're going to multiply it by 2. So we start here at this one again. Again, you can start wherever you want. So I'm going to move it to the left 1. There we go. And then multiply that y value by 2. That would put me at 8. And I really don't have much room, so I'm just going to make that point all the way up there. It's about 4 units up. Over here, I go to the left 1. Multiply that y value by 2. So my y value is 3 there. That times 2 gives me 6. Come down here to B. Oh, I must have deleted those coordinates on accident. That's alright, you know what they are. Move it to the left 1 again. Multiply that y value by 2. That y value is 0, so it's just going to stay put there. It doesn't move anywhere. And then I take this one and I move it to the left 1. And remember, you're multiplying the y value by 2, and my y value at this point, or where it was originally, was negative 1. So I take negative 1, you multiply that by 2, it gives you negative 2. So that's going to move me here. So you see we doubled our distance from the x-axis. That's essentially what's going on. And so we'll end up with a function that looks similar to what we had before, but it has been stretched out and moved in one direction. And it looks like I need to move something. There we go, because I couldn't see that one all the way up at the top. So it's been stretched way, way out and moved to the left 1. Alright, and so that's shrinking and reflections for this example. You can imagine that things are going to be similar in other examples. Remember, if it's inside the parentheses, that's a horizontal translation, and the signs don't make sense. So if it says positive, you go to the negative direction. That is to the left. And if it's negative, you go to the positive direction. That's to the right. And if it's outside the parentheses, addition or subtraction, that's a vertical translation, up or down, and that does make sense. And if you're multiplying by f of x, that means you're multiplying the y value. You just need to find out whatever that y value is, wherever you're at, and multiply it by whatever that value is up there. So sometimes it'll be negative and sometimes it'll be positive, and you move accordingly. Again, if you have any questions, leave them below. Math-A-Fanatic, I'm out.